confusing. Okay. So if we say, let's see, if we go around, we pick the left loop, right? And let's see, we have two eyes. Where's my other term?
3 eyes.
So I1, I2, and I3.
Yeah.
Oh, right. Okay, yep. So, let's see, they have it going.
Are they both going to go clockwise or opposite?
Let's see, what did I write out? This was I1 minus I2 plus I3. So we're going so we're going into the batteries, I guess, right? And then we're coming out of point P. Oh, we're going into the resistor. Where do I have?
Can't we just look at the outside loop because it's all wired in series? I mean, I don't know. Since we know the voltage of all of the resistance in the outside loop.
Yes.
And then we can solve for I1 and I3 that way. And then if we know the total voltage on the system and total resistance, we should be able to find the total current. And then just subtract using the I1 minus I2 plus I3 equals the total.
Okay. No, I gotta. Okay, so yes, you're on the right track. I just have to back up a little bit because remember I was talking about Kirchhoff's voltage and current laws for your junctions. Whatever's going in is going out, right? So if we, yes, we're going to look at the whole loop, but we want to look at P and Q, nodes P and Q, and define what's going on with those, right? So what I was doing with that first one was, see if I write over here, so this is node P. So node P, these guys are plus, adding to node P, and I is going out of it, so we're going to call it minus. So then if we look at node Q, right, how would we define node Q for I1? Is it going to be plus or minus?
Minus.
Minus. And then for I2, plus. And for I3, minus. Okay, so that takes care of the Kirchhoff part, or at least as far as nodes P and Q. So now we can go back to the loops. It makes more sense if we start with the nodes than instead of the loops like I was talking about. So if we say loop on the right, okay, so what do we got going around that loop? We've got 10 ohms and 90 volts. Or no, we've got 25 ohms, right? 25, 35, 25. Well, 25 at I3 and 10 at I2, right?
That'd be
Does that make
series,
sense?
right?
So I have 10 at I2 and 25 at I3. What am I going to do with that 90 volts? Well, yeah, or put it over here, right? Because of Ohm's law, we know that what current, is it current times voltage equals the
V equals IR.
V equals IR. There we go. So V equals IR. So current times resistance. So we're defining our current and our resistance, and it's going to be equal to the voltage. So let's do the loop on the left. So we're going to have what? Our resistance is 20, and we're I1, right? And we have, and I2 is at 10, and we're equal to 80 volts this time. Okay, so that gets our system of equations set up. So let's work through our example. Oops. So I'm just going to change these to X's just for I don't know, just because I can, I guess. Plus 1. And this is supposed to be 80. So these would be our equations. And this would be our matrix. So we're going to have what? 1, minus 1, 1, and 0. Minus 1, 1, minus 1, 0, 0, 10, 25, 90, 20, 10, 0, and 80. Okay, so that's what this would look like in matrix form versus equations. And in the matrix form, the equal signs are there, they're just invisible. Okay? And so we have what? 4 equations and 3 unknowns. So we have what would be a overdetermined matrix, meaning we have more equations than we have unknowns. And an undetermined or underdetermined matrix would be we have more unknowns than we have equations. And a determined matrix is just you have the same number of unknowns as you have equations. So we should be able to come up with a solution for this. So again, we're going to do Gaussian elimination, except for we'll set it up a little bit differently. But is that questions about this? Is that making sense so far? Okay, you're kind of following. So, and you'll get opportunity to practice this Gaussian elimination anyway. Okay, so again, we're going to call this the pivot. And we want to eliminate those. So this time we're going to. Why did I do that? Screw that in a little bit so it doesn't fall out. Okay, so we're going to do that. We're going to subtract -1 times. I should write block so you can read. Right? And we're going to subtract 20 times pivot Does that make sense? Because we're trying to get those terms to go away, right?
So in the first one, did we not do that then?
Yeah, we did the same thing except for we'll do it differently this time. I'm gonna do, well, here, I'll show you what I'm gonna do real fast. So we can do, if we're gonna do the algebra, we do -1 times, so this is the pivot equation, oops. The first way we did it, we solved for x1 in that equation and substituted it in the other and did algebra and got rid of them. This time we're going to do row operations and do math. Right, so this is going to be what, -x1 plus x2 minus x3 equals 0. So equation 2 is -x1 plus x2 minus x3 equals 0. So that's equation 2, right? Minus, well, our pivot equation, which is now x1 plus x2 minus x3 equals 0. So this minus transfers through, right? So this becomes a plus, that's a minus, this is a plus, 0, 0. So this all just ends up going to 0. Does that make sense? Piece of cake, right? Okay, and then if we do, what was the next one? Oh, 20 times the pivot. We'll get 20x1 minus 20x2 plus 20x3, and that's still going to equal 0. Equation 4, what did equation 4 look like? It was 20x1 plus 10x2 equals 80 minus 20x1, well, I should probably do that just so we keep it straight, minus 20x2 plus 20x3 equals 0. Okay, so what's that going to equal? You guys know how to add and subtract.
Equals 80.
Huh?
Are you is this the middle of the 2 hours or is this the end of the hour?
Middle of the 2.
So we cancel our 20. We got a
I'm
minus 10.
recording.
Hi.
Yeah,
How
he's
you
on.
doing? Good.
So this is 20 minus 20 is gonna be 0, right? 10 plus 20 is gonna be 30x2 plus 20x3 equals 80, right?
Should be minus 20.